Hello, my name is Cristina Moreno, and the project I've been working on is breaking the lignin barrier with termite TAV5 treatment technology to biopower and biofuel from agricultural waste. The problem statement: biofuel can be considered one of the best alternatives to fossil fuel. Currently, the world produces 3,758 times 10 to the power of 6 megagrams per year, while the U.S. produces 488 times 10 to the power 6 megagrams per year of crop residue. The agricultural sector consumes about 1,714 trillion BTUs per year. It is estimated that anaerobic digestion of this agricultural waste can produce 22 billion meters cubed of biogas. This provides a great opportunity to use biogas from agricultural waste to make this sector more sustainable. However, lignin degradation is a big issue for lignin cellulose waste. Traditional physical and chemical methods to degrade lignin cellulose waste are usually costly and can produce toxic substances. The introduction. Termite hindgut bacteria can break down lignin in wood. TAV5 is the fastest growing microorganism that is isolated from the hindgut of Reticulotermes flavipes termites. TAV5 is known to grow in aerobic and anaerobic conditions. This is unique because most of the pathways for biologically degrading lignin are aerobic. 4 types of agricultural waste are rice husk, rice straw, wheat straw, and corn stover. They're going to be used in this research. The goals and objectives. The overall goal of this research is to break down lignin and boost the production of methane from agricultural waste. The specific objectives are: 1. Finding the optimal conditions to grow TAV5 at a large scale. 2. Determine the optimal ratio of TAV5 with respect to methanogens. 3. Run a pilot scale study to find the boost in methane production by the addition of TAV5. The Objective 1 methodology. Initially, TAV5 was grown on agar plates at 25 degrees Celsius. The temperature was increased incrementally from 25 degrees Celsius to 40 degrees Celsius, and the growth was observed. TAV5 was transferred from agar plates to broth using 5 millimeter tubes, and the growth curve was obtained. TAV5 was grown in 1 to 2 liter Erlenmeyer flasks. Objective 2 methodology. Serum bottles were used as batch reactors. Rice straw, corn stover, and wheat straw were grounded while rice husk was used as is. Sludge from the Village Creek wastewater treatment plant was used as inoculum at a ratio of 2 to 1 with respect to the substrate. Ratios of TAV5 to methanogens were tested from 0% to 90% with 10% increments. Batch reactors were flushed with nitrogen to create anaerobic conditions. The gas production from batch reactors was observed for 3 months. Objective 3 methodology. Tote tanks are used as digesters, 4 with TAV5 and 4 without. Each reactor was painted black to filter out light going into the digester. Rice straw, corn stover, and wheat straw were grounded. Sludge was added to the batch reactors, and the optimal ratio of TAV5 to methanogens obtained from the lab scale was used. The gas production will be observed for 2 months. The Objective 1 results. We can see the growth curve for aerobic and anaerobic conditions. The growth curve shows that the peak growth occurs between 50 and 62 hours. The growth curve was verified by using a cell count analysis. We can see from the cell count that on day 3 the microorganisms are still alive. The results for objective number 2. The lignin content was measured for all 4 wastes using the Classon lignin method. The optimal ratios between TAV5 and methanogens were found to be 30% for corn stover, rice straw, and wheat straw, and 60% for rice husks. We can see from the graph that there is a boost in methane production from each waste. The average increase of methane production ranged from 19% to 71%. The results for objective number 3. We are currently taking readings. Therefore, we do not have the end results. The graph shows the methane production from rice straw, corn, stover, and wheat straw when no TAV5 was added. For our digester of rice husk, it has failed because it was pre-treated with toxic substances. We are currently in the process of getting a new batch of untreated rice husk. The conclusions. For objective number 1, a growth curve was developed and verified at both aerobic and anaerobic conditions. For objective number 2, optimal TAV5 to inoculum ratio was found to be 60% for rice husk and 30% for rice straw, wheat straw, and corn stover. And for the conclusions for objective number 3, the pilot scale is still ongoing. Thank you.